Hello friends, welcome to Qamar MoonBoy channel, and this is Etabs 2015 tutorial continuation part for truss design and analysis. So in previous part, that is in part 1, we have completed our truss member drawing. So we have drawn a Howard truss, and that is English truss, and we have placed the purlins and the slab, that is sheet roof, we have placed on the top. Now in this tutorial we are going to start with the application of loads on this and how to analyze and design. In this part we will see in continuation. Let's start. So for applying the loads, we have to know what are the loads coming onto the sheet roof. So most of the sheet roof truss, we have the loads, like you can see this link, that is on collabs.com. You can find the subjects, and based on this you can find the details, that is loads on roof truss. The loads are coming on roof trusses are dead load, imposed loads, wind loads, and other loads like uh, ice load and other types of loads. Okay, so we have already provided a 3 mm thin sheet roof on this, so we need not to provide the dead load for that. But if you want to provide the dead load, then you have to convert this roof into none, that is null shell. You have to convert this into a null shell. So what is a null shell, and what is a shell without any stiffness? So we have selected this as a stiffness free, that is we have taken this as membrane slab, so we need not to convert anything. But you can see that there are two types of slabs here, that is shells with no stiffness. We can provide it in Etabs in two types, that is defined shell objects with their actual thickness that we have did, and in property modifiers you can multiply that with 10 power minus 3, that is 1 divided by 1000 you have to do for the stiffness modifier. That is that these slabs do not provide any stiffness to the structure. So or you can use the null areas, that is nothing but the null slabs. So you can use that, and you can provide the uniform loads, that is dead load and live load, you can provide to that slab. So let us look at the loads now. So that is for GI sheet it is 85 Newton per meter square, and like this only you can write on that loads while application, and you can go and apply the shell loads. I will show you, but I am not going to provide the dead loads. I will be taking the live load. Let us see the live load, that is imposed load. That is, it is given as up to 10 degrees slope. It is 0.75 kilonewton per meter square, and it is taken from IS 875 part 2. You can see here. So this is for 0.75 for 10 degree. If there is any change in degree, that is 0.02 degree, that is degrees minus 10, you can do for this. So 0.75 is the maximum load, and for 10 degrees, so we are going to take this maximum only for the live load. We are not going to reduce it by 0.02 for any of the degrees, because we are not going to calculate how many degree our truss is now. So let us continue with this live load. Then we are going to provide the system developed wind load. Let us continue and go to the slab now. Now for selecting all the slab sections, go to select, then again go to select, properties, okay, then go to the slab sections. Now select the sheet roofs. The sheet roof got selected. Then go to assign, Then go to shell loads, uniform shell loads, then provide this gravity load in the for live, that is you take 0.75 kilonewton per meter square, apply. OK. Then you can see in 3D that the load 0.75 live load has been applied to the structure. Now for applying the wind loads to the structure, you can go to define, and in load patterns just add a wind, take the wind and select Indian code for wind loads, that is IS 875 1987. Add new load. Select this wind load here. In the define load patterns, we have defined the wind load. Now select this wind load and go to modify lateral load. Now for Hyderabad, you can say you have 33 meters per second. That minimum wind speed you have to take, because uh, we are considering this truss roof at the bottom. If you are taking at the top of the any other structure, then you have to consider that height, and you have to take the top story wind speed you have to take for that. Terrain category is 2 for Hyderabad, and structure class is B only. So we are not changing any structure class in that. Windward is 0.8 and leeward is 0.5. That's okay. We can modify and show the directions here, which is not required at this moment. Top story is 2 and the bottom story is 1. Okay. Press on OK. The wind load has been added. Press on OK. Now check for the before the analysis. Go for Analyze and check model. This is in the analysis step. So select all these things and press on OK. If you haven't saved the file, then it will ask for save the file. After the checking of this model, it will show the model has generated no errors. If there are some errors, then you have to correct that errors. So you can see the model has been checked and no warning messages was generated. Then our structure is okay and ready to go for analysis. Now go to Analyze and set the model case to do not run by clicking on the do not run here, and accept this model case that dead load, live load and will load we will be running now. So press on run now. So until the analysis is running, I will be giving you all this uh, documents list, that is colabs.com, and the CSI knowledge base shells with no stiffness. These links I will be providing you in the description below. You can go to that and you can subscribe and share this video with your friends. So let's see our analysis is complete or not. Yes, our analysis is complete. You can see the purlin at the top is showing abnormal behavior because of the load coming onto that. So that doesn't matter. We have selected the auto select, then it will select by itself the auto selection of that, and it will take a good decision on that, because we have to provide a I section here if it doesn't satisfy the design. Actually, because we have a heel top on this, you can see we should have a we should have we should have a ridge here. Actually, there is no purlin here, so purlin will not be there here. There should be a ridge here, and we have placed that purlin just for drawing the slab, so that will not affect the design whether it fails or pass. It doesn't matter. We this truss member what we have taken, and this column should pass the test, and these purlins should pass the test. So let us see the design now. We can before going to design, we should see the dead load displacement is there, you can see here, and by pressing this button, next button, you can see the due to the displacement due to the live load, and the displacement due to wind load in x direction and y direction, you can see. Okay, so these are the effects due to the wind load, dead load and live load. And you can see now the by pressing on the display frame spandrel and going to any load, and for the frames for moment 3, you can see the moment diagrams. Press on apply and OK. You can see the moment diagrams, moment generated, or the tensile axial forces you can see on this. So by right clicking on any of this, you can see the generated moment or shear force, whereas the truss will not take any moment. So in design we will be selecting it as a truss design, then it will not take any moment and it will go as a truss. Okay, go to the undeformed shape. Now go to the design, and then go to the steel frame design, go to the view references, and you see that it is IS 800 2007 is selected in this, and these are the definitions you can see here. We can change these if according to your requirement, you can change that one. Now select all the steel members, press on all the members will be get selected. Go to design, steel, lateral bracing, then select program determined, press on OK. All the lateral bracing will be done. Now go to the design again, steel frame design, and before going to the start and check design, we should check whether our members are in steel frame design or not. Right click on any member, go to the design part, you see that here it is steel frame design. And for slab, there is no design for slab we are doing here, because we are going to provide the sheet. So you can verify it here. If it is showing any design, then we are doing wrong. So next, go to design now, and steel frame design, go to the start and design check. The design process has started. So it will take some time. Until then, you just Share this video and subscribe for more, and also follow few of the books given here for the details you can find on this. You can find go to bottom of this file, and you can find few of the reference books have been provided by uh, this notes, and these notes you can follow, that is design of steel structure by K.S. Ram and Ramchandra and S.K. Duggal. These two books are really well. That this sound seems that our design is ready now. So after design, it is showing that analysis and design differ by uh, 127 steel frames. That is what the analysis have been done, that is not designed. After design, the analysis members has changed because we have selected the auto frame sections. Now do you want to select those? No, for now time being I don't want to select those, so press on no. And you can see that analysis and design differ by 127 steel frames, that is that has been changed. So we want to select them. No, for time being. So you can see that what are the purlins and what are the frames has been select given now. By right clicking on that, you can go to details now. You can see the steel frame design here. Okay, so you can see that analysis section was taken as ISHB 225. Now in the design section it is taken as ISWB 600. So this is the difference. So the column has been taken automatically as ISWB 600 by the program. You can override that one by pressing on overrides. So current design section you can see here, and you can change that one according to your requirement. You can change that one, but it is the highest one. Okay, now we have designed the section and all the section has passed the design except this purlin. So we are going to delete this purlin or remove this purlin for time being. So go to the design one again. You can see this message again by verify analysis and design section data and verify all members has passed or not. Then now we go to we will reanalyze this one with this new members. We have reanalyzed this one. Now go to design again, start and design check. So after running two or three times these designs, all the sections will match. Then that will be your end of your design, and that purlin which is showing red mark which got failed will nothing but we can change that, and you have seen that there is no purlin required at that point at the site, so we need not to change that one. Again you see a message that 82 steel frame has differ from the analysis and design. So now, do you want to reiterate the analysis and design? You can select now yes again. So it will do analysis and design again. Let us skip it to the last and let us see the final results. Like this, after several iterations, we will get the no difference in the after several iterations like this, we get the final answer as no section has differed the analysis and design, and all the sections has passed. Make the auto selector section null now. Then design. After several iterations, we are designing again. When no analysis and design sections are changing after several iterations, then we are designing it again after setting the design section null. So after doing several times iteration analysis and design, and after uh, providing the point bracing to these three columns, these were failing. So we have provided the point bracing by going to by selecting these columns and okay, and by going to design, lateral bracing, then user defined, then specify point bracing. Then we have added point bracing at relative distance of 0.25, 0.5 and 0.75. Three bracing we have added to these three columns. Then we have run the design again. Then these columns are safe. So these columns are taking heavy loads. That's why it's required point bracings uh, uh, apart from the program defined bracings. So these bracings the program defined bracings are at the end, so that is at the top, at the bottom, but we have provided for these columns at point bracings at 0.25 distance and point 0.5 distance and 0.25 distance, that is the relative distance. So yeah, if you divide these height into three distances, that is four distances, then you'll get at 0.25, 0.5 and 0.75 distances. So these you have to change, and your column will be safe after that. If the design from the program it is not coming safe, then you have to do that this step. Otherwise it is not required if you are taking less loads or different design or different truss. So based on my truss, I have got these failed columns, then that is in the red zone. At the time I analyze and design for the first time, then I have iterated for several times, and I have made the other columns safe, and at last I have to change the point bracings for these three columns because it was not coming safe. They were in the red zone, now they are in the yellow zone, you can see as it now. But the purlins at the top which are failing, that is six, that is nine numbers of purlins, you can see no, six number of purlins, sorry, I have to deselect these three. Okay, six numbers of frames selected, you can see at the left bottom corner. So these frames, that is purlins, are not at all required at this top. We have just provided for the uh, slab provision of the slab properly at the top. For that we have provided to divide the frame into two sections, we have provided that there, but that is not required. So by this you can see that our design is safe and all the members has passed the design. So except these six purlins which are not required to place on that point. So we our design is passed, our analysis is done, and like this you can see all the design, you can do the design of truss, and you can see the details of the truss by going to this details option here after right clicking on the member, and you can do override for that member if you don't want that member. So here we conclude this tutorial, and you can ask in the comments below whatever question arises in your mind for this tutorial and other tutorials we have done before. So here we end the truss design and analysis part using IS Indian, that is IS 800 2007 codal provision. So for more videos and tutorials like this, please subscribe my channel Qamar MoonBoy, and do share and like this video. Thank you so much.